Cool. So basically, guys, the agenda for this is to discuss all the four problems of this weekly contest 414, right? The very first, so I will say that there are four problems, and this contest was kind of a greedy contest. Like all the four problems, if you will see, they are actually solved using the very brute force and the greedy approach. I will say not the brute force, but the greedy approach. See, the very first problem is, as usual, a basic brute force problem. Second and third were tricky problems. This seems to be a DP problem, and if you will see, I think they can also be solved using DP. There is a possible way of solving that, but DP will take more time complexity, right? So the better way of solving this problem was actually using greedy, or second also and third also. Third also can be solved using dynamic programming using order of n square time complexity, right? But if you will see the constant, you have to solve it in order of n. So first problem was as usual, we see Leetcode first problem is very basic, greedy problem, a very brute force problem. But if you will see the second and third problem, interestingly, they are also greedy, but of a good level. Not very easy, right? They were uh, good level problems of greedy only. No DP, nothing complex involved. If you will see the solution also, they are plain solution of binary search and basic greedy. Fourth problem was actually very interesting, right? So I searched for multiple solutions and I got this a very good solution of this, which is clearly explained also, and which is having a very great approach of it. This problem was a brute force problem. You must be wondering, sir, how brute force is possible? It is possible. And it is again bit masking with DP with some graph. So it is graph plus DP plus bit masking. That kind of problem it is. This problem will be the problem that will take a lot of time for us to understand. Others are not that much difficult, right? So if you will see why I'm saying it is a greedy problem, because the constants are very low. Max the value of, you can see this chessboard is just of size 50 into 50. From here only it is visible that it is a brute force problem. There is no much optimization that can happen here because your limit is just up to 50 into 50. Right. And if you will see the positions of the knights now, they are also up to 15 only. Means there will be max to max 15 knights that will be present. Okay. So this suggests that we can implement actually bit masking here. How? That I will explain, right? So these are the problems. Let's start with the very first problem, the very first, very basic, very brute force problem, with this convert date to binary. Am I clearly audible and screen is clearly visible, right, to everyone? Ritu and Abhinav?
Yes, sir. It is clearly visible, sir.
Okay. So let's talk about this problem, convert date to binary. Go. This was a very basic brute force problem. Problem kya hai? You are having a date in this format where first you have year, which is mentioned with 4 digits. This is the year, right? This is the month, in which month you are, and this is the date. Okay, that is what is given to you. Now what you have to do is that you have to convert the year into its binary representation, month, and then date into its binary representation. So ultimately, if you will break down, this problem is a problem where you have to convert an integer into its binary representation, right? That is the problem, right? So for this problem, I was already having a this function in my template. If you will see my CP template, so if you will see, this is my CP template that I use in Code Forces and Code Chef, not in Leetcode actually. I don't prefer it to use in Leetcode because in interview they mostly ask Leetcode questions, and I can't use this template in interview, right? So I don't use in Leetcode, but yeah, in CP I mostly use this template. So if you will see in my template, I was already having a function which was this decimal to binary. So this function, ये क्या करता है? This function actually takes an integer n, and then it converts it into a binary number, into a binary string, And how we can convert it? That's a very basic thing. For example, if you have a number, let's say 29, how you can convert it to a binary string? So you will divide it by 2. Whatever is the remainder, that will be the part of our binary string, we all know. For example, when we divide 29 with 2, remainder is 1, remaining is 14. Then again 2, remainder 0, 7. Again 2, 1, 3. Again 2, 1, 1. So final binary representation of 29 will be 11101, right? And you can see here it is 11101. So we take from bottom to top, right? So I hope this is clear to everyone that how we convert a decimal number into a binary number, right? And that is what is happening here also. So we are having a number n, while n is greater than 0. What we are doing, we are dividing it by 2, and every time whatever is the remainder, we are storing it in a string, and then we are returning a string. This is how we are converting a decimal number into a binary number. Does it make sense to everyone? Ritu and Abhinav? ये
Yes,
function?
sir.
Now it is very basic. Now we just have to do two things. I have to first take out these first 4-digit number and convert it to binary. Then these 2-digit number convert it to binary, and these digit number. Right. And if you will see the indexes of this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I'm doing, first I'm taking the first substring of this date. So I'm saying date dot sub str from 0 to 4. So what it will do, this substr 0 to 4 will give you these 4 digits, first 4 digits. And then I'm doing stoi. Stoi is a function that converts a string into an integer. So now I have this much number as an integer, 2080. And then using this function decimal to binary, I'm converting that integer into a binary string. Okay. And then I'm storing it in the answer. And as usual, जैसे यहाँ पे dash है, we have to add this hyphen here also. So then I added a hyphen. Then for the next 2 digit, which is from 5 to 7, this I have taken, which is the month. I converted to integer and then again to binary. And then lastly, the date from 8 to 10. Right. And this is how we are solving this problem. Does it make sense?
Yes, sir.
Okay. Ritu, Abhinav? Cool.
Yes, sir.
So this is what we are doing here. It was a very basic problem, okay, that we are actually doing. If you will see the time and space complexity is order of n, space complexity is constant, but time complexity is order of n because we are using substring function, right? So, and this is like nothing. This will just take log of n time. So we can say something like that, but yeah, again, it is more and how constant only, right? Not much. Now let's move to this next problem, maximum score of numbers in ranges. This was actually a very good problem. See, this problem seems to be is to be a dynamic programming problem. How? Because see, देखो हमें करना क्या तो problem है क्या? Let's first understand the problem. Problem says that we are given an array of integer start and an integer d, where which is representing n intervals from start of I to start of I plus d. ठीक है? So each element in this start array is representing an interval. Let's take it as an example. For example, this is the test case we are considering. ठीक है? अब if this is the start array and this is the value of d, so we have three intervals. First from 6 to 8. So basically 6 to 6 plus 2, 8. Okay. Then next is 0 to 2. And next is 3 to 5. So basically plus 2 tak har number pe interview aa jayenge, right? Now next what they are saying? Next they are saying that you have to choose n integers where each integer belong to each interview. So for example, इस interview से मुझे एक integer निकालना. Let's say from here I picked out 7. Let's say. Then from here I picked out 0. Then from here I picked out, let's say, 5. So from all these intervals, I picked one number which is present in that interval. जैसे यहाँ पे 7 present है, यहाँ पे 0 and यहाँ पे 5. Okay. Now what we have to do? So we don't have to just pick these numbers. The thing is, we have to pick the numbers in such a way that score of these numbers is maximum. But what is the score? So score is defined as the minimum absolute difference between any two integers that can be chosen. So जो minimum difference होगा इन सब में से वो आपका score होगा, and you want to maximize that score. Means you have to maximize the minimum difference between the numbers. That is what the problem is. And guys, this kind of problem actually presents in Leetcode. I don't remember what's the name of that problem, but this problem actually, that you have an array and you have to find the maximum possible minimum absolute difference, right? For example, यहाँ पे अगर आप देखो, when I've chosen 7, 0 and 5, what's the difference, and not just to adjacent numbers, no, through every pair. तो क्या करें हम लोग, पहले इसको सॉल्ट कर लेंगे. So it will be 0, 5 and 7. Because after sorting, their adjacent will give you the minimum difference. तो ऐसे यहाँ पे difference आया 5 and यहाँ पे आया 2. So what's the minimum difference? 2. तो हमारा score इस केस में हो गया 2. 2 is our score. Right? Does it make sense?
Yes, sir.
Does it make sense? Right. Now we have to maximize this score. So we have to choose these integers in such a way so that we can maximize this score. We can maximize this score. अब कैसे maximize कर सकते हैं? That is the very big thing. Right. अब देखो, first of all, we need to understand one thing, that we need to sort this start array in increasing order so that this numbers that we are choosing, that should be also in the increasing order. Right. Up, you will see, Abhinav, how we can rearrange the start array, because we have to find a difference of two numbers. See, that is what the case here. Many people got confused in this thing. So they are saying that you have to find the difference of any two integers that has been chosen, not the adjacent. अगर adjacent बोलता तो हमें उसका जो ordering है, the ordering of the array we have to conserve. But here we don't care about the ordering of the array or the ordering of the integer. We have to find the difference between every two integers. And the minimum difference we find when we take integers in the increasing order, right? So what we will do is that हम सबसे पहले इस array को sort कर लेंगे. So after sorting, this array becomes 0, 3 and 6, right? इसका logic आपको पता है. अब देखो, here comes the main logic that how we can solve this problem. See, first of all, you can't solve it directly using greedy. So many people told me, okay, Abhinav, here these are the start points 0, 3 and 6, and if I will say something called end point हो जाएगा, सब में +2 कर दो, so 2, 5, 8, okay, and then we can check for every number in between, every possible combination, but that will be a very huge time complexity of n into d, right? And if you will see n here and d here, बहुत large है, बहुत ही large है, it will give TLE. It cannot be solved using all the possible combinations. So how we can do? For the better thing, what we can do actually here is we can solve it using binary search approach. So what we have to actually do, we have to find integers such that their minimum difference is the score. So minimum difference of the integers is the score, and you have to maximize it. So what if we apply binary search on answer? What do you mean by binary search on answer? Binary search on answer means that we will hit and try. We will first try for a value, let's say some value. Okay, then we will try for some other value and so on. So we'll hit and try. ठीक है. और अगर आप एक चीज और देखो, तो जो रेंज होगा नंबर्स का, वो कहां से कहां तक वेरी करेगा? That will vary from 0 to 8. जो डिफरेंस होगा वो 0 to 8 के बीच में ही होगा, उससे ज्यादा नहीं हो सकता है, राइट? तो हम क्या करेंगे, that first of all we will sort this array start. Now I will apply binary search. ठीक है. अब initially we take L0 R 10 to the power 12. By the way, you can take it, but we have taken the maximum whatever which can happen, right? अब देखो आप, what we did, we are checking for every possible combination. For example, L0 है, let's say L is 0 and R is 10. For example, in our case, हम लोग पूरा नहीं चेक कर रहे हैं from 10 to the power 12. ठीक है. Now we will apply binary search on answer. We will get a mid and we will check that whether for this mid is the answer possible. If answer is possible, storing the answer and then check for a higher mid, because we have to find the maximum value which is possible, right? तो अभी हमारा mid कितना हुआ? Mid is 5, right? Now let's check that whether difference of 5 is possible or not. Whether difference of 5 is possible or not. How we can check? So we have a start array like this, 0, 3 and 6. It is now sorted, right? We have sorted it. ठीक है. Now what we will have, कि we will have our integers, ठीक है? तो हम initial जो integer होगा उसको हम 0 ही मान लेंगे. Let's say this is our p, which is currently 0, which is the first index of our start. हमने इसको 0 मान लिया. ठीक है. अब see, now if I want, if I want a difference of 5, if I want a difference of 5, तो जो next number है, that should be have a minimum difference of 5. 5 से कम तो हो ही नहीं सकता, ठीक है? The difference cannot be of less than 5. Do you agree, Ritu? Because we are trying to make the
Yes.
difference 5. ठीक है, we want to make a minimum difference 5 between any two indexes. So if we are considering, और हमें पहला वाला, ओके, मेरी आवाज आ रही है ना आपको?
Yes, sir, आ रही है.
Okay, great. So यार,
सर पिक कर ली.
sorry guys. हाँ, so I'm audible, Ritu, Abhinav?
Yes, sir.
ठीक है, okay. हाँ, so basically if we have initially taken our I, this is an integer I, तो हमें n integer लेना वही है. Initially we have taken our first number as 0, right? अब because we want our mid as 5, so we will plan कि जो next number हो minimum इतना हो, minimum it should be p plus m only, right? But there is one more thing, that p plus m should be in the range of this pair ना, this interval. और इस इंटरवल की रेंज कितनी है? 3 + 2 5 तक है, ठीक है? तो क्या ये 0 + 5 इस रेंज में आ रहा है? यस और नो? इज इट कमिंग?
Yes, sir.
इट इज कमिंग, राइट? तो इट्स फाइन. नाउ लेट्स चेक फॉर दिस. अब यहाँ पे क्या होगी, नंबर क्या होगा यहाँ पर? व्हाट्स द नंबर?
8.
10?
6 + 2 8.
नहीं नहीं नहीं, ये 5 है. अगेन वी वांट अ डिफरेंस ऑफ 5, राइट? तो
Yes, sir.
व्हाट शुड बी?
10.
10? 10, right?
Yes, sir.
We want a minimum difference of 5, right? So it will be 10. But is 10 possible here?
No,
To come
sir.
here? No, right? So means difference of 5 is not possible. Difference of 5 is not possible. That's a basic thing. ठीक है? Now let's check for a lesser value. अब थोड़ा कम वैल्यू चेक कर ले, ठीक है? Now let's check for 1. अब चेक करते हैं 1 के लिए. लेट्स कि क्या 1 डिफरेंस पॉसिबल है? ठीक है? अब देखो, ये 0 है. वी वांट मिनिमम डिफरेंस 1, मैक्सिमम और ज्यादा हो सकता है, कम नहीं होना चाहिए, राइट? अब देखो, इसके लिए नेक्स्ट क्या आना चाहिए यहाँ पे ऋतु? व्हाट्स द नेक्स्ट आफ्टर 0?
सर 4 3 + 1 4. ऐसे 1 होगा वहां पे.
तो ये 0 है, राइट? दिस इज
Yes, sir.
0. Our previous integer was 0. We want a difference of 1, minimum difference 1. So here it should be 1
1
practically.
1
But
आना
is
चाहिए.
1 possible here?
No, sir.
1 is not possible, right? But you will see 1 is actually less than the star. तो 1 तो possible नहीं है, but हम उसकी कोई बड़ी वैल्यू रख सकते हैं. We can place a higher value here. So which value we should place here?
3.
3, right? 3 is the value which we can place here, which is minimum also and which has a good difference also. Up next, what should we place here? 4.
4
That
और
we should
6.
have 4. But 4 is not possible with 6. ठीक है? इससे क्या दिखा हमें कि या difference 1 is possible. Difference 1 is possible. But we want a greater. Now let's check for 3. क्या 3 possible है? And 3 you can see it's visible, it is possible. Right?
Yes, sir.
इसके लिए वैसे 4 होगा. I think 4 भी possible है. Let's see how 4 is possible. So now let's say if mid will check for 4, how we will get the answer? So we'll start from 0, then 4, and then 8. That's it. Right? So if we will see what is the how we are implementing this. So we got a mid M. Initially P is starting from start 0. Up C. If P plus M is within the range of start I and start I plus D. If P plus M is in the range of start I and start I plus D. Are you getting?
Yes, sir.
That means in this P, we'll add M. For example, यहाँ पे 0 था, we're adding 4 and 4 was in the range. तो हो गया. Right? We simply added. Second case was when it is not in the range, but P plus M was less than start of I. When this case happened, when our difference was 1. So if you remember, when we were taking our mid as 1, so this was not in the range, but this was less than 3. So we made it 3. So it was less than range, but we made it 1. Right?
Yes, sir.
And
Start
if
value
even
only.
it is not possible, for example, for 5 it was not possible. So we will simply make OK false. But if for a given M, if it is possible, make answer equal to M and then check for a higher range. Makes sense, right?
Yes, sir.
So this is simple binary search on answer. So we are hitting and trying for the given value of M that whether it is possible or not. Okay? Is this question clear to you, Ritu and Abhinav? And if we'll see the time
Yes,
complex
sir.
is a order of N, right? Binary sets में order of log of j लगेगा, but it is just constant. If you will see, we are taking it as constant for now. It will be n log n, we can say, or n log not d. Yeah, but we can say that. Still, it will be very small. Right. Makes sense. So this is how we are solving this problem. So can we move to the next problem?
Sir,
Is it
can
clear?
you explain the time complexity, sir, again? Log of for binary
So
set?
basically, देखो, हाँ, तो basically, what binary search will take? Binary search will take the log of r, whatever this range we have taken. For now, you can see that this range was constant, right? So this log of r will also be constant. And in every binary search, we are taking this order of n. So it will be ultimately order of n log of r, where r is the range of our binary search,
Okay, sir.
right? Ritu,
Yes, sir.
कोई डाउट है तो पूछ लो. कुछ क्लियर ना हो तो पूछ लो. हम्म. हेलो.
Yes, sir. Sir, clear है, sir.
क्लियर है. ओके, ग्रेट. ठीक है.
Yes.
ठीक है, cool guys. So we can like move forward to next problem then. This is, I think, say even a easier problem than the second one. Third is a easier problem. This problem says that we are having a nums array, right, of size n, and you have to start from the index number 0. You have to reach index number n minus 1, means from the first to the last index. And when you jump from index number I to j, then the score will be j minus I into nums of I. This is the score that you get, right? Now you have to return the maximum possible total score when you have to reach from 0 to the last index. ठीक है. So for example, let me give you a example case. For example, it is 2, 1, 6, let's say 4, 3, 5, 4, 8, 3. For example, okay. This is 0, 1, 2, 3, 4, 5, 6, 7. N is 8, right? So you will start from the very first index here. From here, let's say your I is. Okay. Let's say if you're jumping from this 2 to this, let's say 5. So the score that you're getting is this 2 multiplied by difference between the indexes, which is 4 minus 0, right? And then you can move forward. And by doing this, you have to reach the last index. Is this clear? Right. So this seems
Yes, sir.
like a job like with frog jump and all of the problem, right? Just DP में करते हैं, but it is actually not that. It is actually easier and simpler than that. How it is easier and simple? Let me show you. See, for example, you are currently at an index C. So when you're jumping from index I to J, ठीक है, तो your value will be nums of I into J minus I, right? This is what your value is. अच्छा मुझे एग्जांपल बताना. फॉर एग्जांपल योर एरे इज लाइक दिस. ठीक है, आप यहां पर हो, अभी आपको यहां पहुंचना है. तो व्हाट विल यू डू? विल यू डायरेक्टली जंप और विल यू टेक सम मिडिल स्टेप? व्हाट विल यू डू, Ritu?
Sir, I will directly jump to the last
You will
index
directly jump to the
from
last
0.
step. Why? Because in between we have smaller numbers than 4. We don't have larger number. Right? Because it will stop somewhere. From there, when we will take the jump, the score will be the difference of the index into that number. So why should we stop in a number which is smaller? For example, अगर ऐसा हमारे पास case है where we have 4, 1, 1, 1, 1, 1, right? If I will say indexing, it will be 0, 1, 2, 3, 4, 5. Okay. And let's say I'm starting from here. So if I will directly jump, my score will be 4 into 5, 20. But let's say if I am stopping somewhere here and then I am going, for example, then my score will be this 4 into 2 plus this 1 into 3. So यहाँ पे 1 3 हो गया. 1 is smaller. Instead of let's use 4 for this whole range. Na? Are you getting? So,
Yes, sir.
so we will only stop when we have a higher number. So for example, when you will add 2, right? The logic is we will only stop whenever we find a number which is greater than 2. For example, we are currently at 2. Next is 1. Okay, why should we stop at 1? We have a higher number 2. तो हमारे स्कोर में 2 ऐड हो जाएगा अगर हम इसके थ्रू निकलते हैं तो. हाँ, next we got a 4. Now we can stop at 4. Now next 3 we should not stop because 3 is less than 4. Next we start at 5. And then next at 8. And then reach. Are you getting?
Yes, sir.
अगर यहाँ पे if we have even a smaller number, let's say यहाँ पे 1 होता, so this 4, this will start from 2, will go to 4, and then from 4 it will directly go to 8, and then to n. So score will be 2 into 2 plus 4 into 4 plus 8 into 1. So we should only stop when we have a higher number because of that higher number, we can have a higher score later. We should not stop somewhere which have a smaller number. That is the main agenda of this problem. So if you will see, initially I am at index number 0. So I made my p equal to 0. So how we are solving this problem? We have our current p. P is the current index where we are, is at 0. 0 index point. Right. Now, when we got a higher index, when we got a nums of I, which is more than p, मतलब ज़्यादा है. So first of all, now my p will jump there. Let's say this is the higher index. So now my p will jump from this to this, the current index. And the score will be the difference of the indexes multiplied by the value of this where the p was. So it will be I minus p, difference of index, into nums of p. And now p will become equal to I. p भी यहाँ पे आ जाएगा, where I was. Right? Then again इसके बाद it will go here. and when it will reach the end, the last index, then simply take it. Simply last index और जहां भी p है उसका डिफरेंस लेके मल्टीप्लाई विद द p. This is what we are doing. Basic greedy approach with a time complexity of order of n and space complexity of order of 1. Does it make sense?
Yes, sir. I also applied this approach on the contest time.
Great, great. Abhinav, any doubt you have?
Clear, sir.
Okay, okay. So now moving forward to the very last problem, a good problem, greedy only, brute force only. We applied dynamic programming here, bit masking here, then also greedy techniques we applied here, shortest path algorithms and all. So we applied a multiple things here. Okay, so let's discuss how we can solve this problem. So basically, let's discuss first of all that what the problem is, right? So for discussing the problem, I will first take a grid and will tell you what the problem is. So basically the problem what we are having is that we are having a knight. Knight means horse in chess, right? And we have a chessboard of size 50 into 50. Here we have of size 5 into 5 for our understanding. Okay. Okay. Now understand very carefully. We have only one knight and the position of that knight is given to you as kx comma ky. So this kx comma ky uh, is the position of the knight where the knight is currently, right? And apart from this, we actually have some pawns there. Pawns मतलब उसको बोलते हैं सिपाही और ये सब जो भी होता है प्यादे एंड ऑल, तो वो पॉन्स हैं, वो प्रेजेंट है एट पोजीशंस एक्स आई कॉमा वाई आई. ठीक है. So those are present and they are multiple, not just single. Here you can see it's a single that is present. We can add some more pawns also. For example, there is one pawn here. This is a pawn, right? Let's say there is one more pawn here, right? There is one more pawn here, and let's say here. Okay. So we are given with a this thing for them. अब देखो मेन चीज क्या है. The thing is that this knight has to kill these pawns, or maybe kill करना है, capture. This knight have to capture all the pawns. सारे pawns को capture करना. And while capturing, what will happen? So it is like a game. तो इतना समझ में आ गया ना. अभी तक हमने जो पढ़ा वो क्या था कि there's a chessboard. In that chessboard is one knight and there are some pawns. Knight is present at kx comma ky and pawns are present at the given positions. This should be clear. Okay. Now let's move forward. Next, Alice and Bob play a turn-based game where Alice goes first in each player's turn. So basically, there are two players, Alice and Bob, as usual, right, which are playing this game. Now, what they are saying is that in each turn, what the person will do, the person will select a pawn. वो एक pawn को select करेगा. For example, मैंने इस वाले pawn को select कर लिया. Let's say I selected this pawn. ठीक है. And then what will happen? That it will capture that pawn with the fewest possible. वो इस वाले pawn को capture करेगा, मतलब capture करेगा, मारेगा, कुछ भी मान लो, with the fewest possible move. जो सबसे कम move लगेगी, सबसे कम move, जो सबसे पास वाला distance होगा, उसके थ्रू वो इसको कैप्चर करेगा. बहुत तरीके हो सकते हैं. फॉर एग्जाम्पल एक तरीका ये, लेट मी शो यू. तो फर्स्ट वे इज कि हमारा जो ये नाइट है वो पहले यहां पर आया, डायरेक्टली उसको मार नहीं सकता है, बिकॉज वो कैसे चलता है, इस तरीके से चलता है ना, ऐसे ऐसे ऐसे. आई थिंक यू गाइस नो, राइट, लाइक दिस. So how it can actually kill? It can actually first come to this place. Okay. Then it can come to maybe this place. मतलब एक तरीका तो ये दिख रहा है मुझे, but I don't want to use that way. I wanted to, because I have to explain something to you. Okay, maybe ये वाला तरीका होगा. तो एक तरीका ये है आपका, that first your horse will go here, your knight will go here, and then it will go here, and we'll capture this point. Does it make sense? Does it make sense, Ritu? This is the shortest path.
Yes, sir.
Just 2 steps we need, such that that knight will reach that point, right? But the thing is that in this process, maybe the knight is moving through some other pawn also, but that pawns will not be captured. It will capture only those pawns which are basically which he has selected. So, for example, because I have selected this pawn, I will capture this one only. Maybe in the path, I am getting some other pawns also. But because I have selected this, only this one will be captured and this one will still be alive. It will not be captured. Are you getting this thing?
Yes, sir.
Right. अब
So
देखो,
basically, sir, I have to choose that pawn for which knight will take less move.
no. Thing is different. So, what you are saying is right. So basically, in practical case, if we have to minimize the number of move, तो मैं क्या करूंगा? तो मुझे पता है, when I know कि to reach this pawn in the path, I will get this pawn also. So first I will select this pawn and will capture it. Then I will go for this pawn. Yes or no? This is the
Yes, sir.
optimized way of doing this problem. But here we actually are not trying to minimize the number of steps. तो इसमें दो लोग हैं. Alice is actually trying to maximize the number of steps, and Bob is trying to minimize the number of steps. तो Alice ऐसे काम करेगा कि जो steps है वो minimize. Let's say if Alice will come, Alice will choose this pawn. So it will come here, it will then come here, it will capture this pawn. So that extra move लगे. अब जब Bob आएगा, Bob will, or if Bob will come, Bob wants to minimize the pawn, so it will directly come and capture this, and then maybe go and capture this. तो बॉब ने 2 स्टेप में दोनों कर लिए, एलाइस ने 2 स्टेप में एक ही मारा, बिकॉज एलाइस वांट्स टू मैक्सिमाइज द नंबर ऑफ मूव्स. आर यू गेटिंग?
Yes, sir.
But this thing we can't determine. We can't determine कि Bob will choose which pawn and Alice will choose which pawn. This we can't determine. There only one way, it's the brute force way. We have to check for all the possible combinations. कि let's say अगर पहले Alice इसको choose करता है, फिर Bob इसको choose करता है, फिर Alice को choose करता है, तो क्या होगा? I have to check for every possible combination. That if first Alice will choose this, then Bob will choose this, and so on. Right? All the possible combinations we have to see until all the pawns are captured. And when all the pawns are captured, whatever is the number of moves, the maximum number of moves that are possible, वो हम return कर देंगे. ठीक है? और 2 टर्न होंगी. In first turn, Alice will come and it will try to maximize. Then Bob will come, it will try to minimize. ठीक है? So we will discuss. It's not actually much complex, guys. Don't worry. It's a brute force approach only. If we need to optimize this approach, then it will be very complex. Okay. So first of all, guys, we need to pre-compute something here. What do we need to pre-compute? So for pre-computing, we actually need to pre-compute the distance or the shortest distance between any 2 indexes in the cell. For example, अगर हमारा knight यहाँ पर है, and it has to kill this pawn. So we should know na ki what's the shortest distance to reach here, which is 2. So basically we have to find the shortest distance between every 2 cell of this grid. Does it make sense? Then only we can move na.
Yes, sir.
You should know. By first night will come here and will come here with two steps. Then it will go here with some steps. But we should know that step. We cannot find it at the real time because we have multiple recursion calls. It's a DB problem. अब shortest distance कैसे निकालेंगे? How can you find shortest distance, shortest moves? Again, graph, right? Graph. We all know. So
Yes, sir.
you can see we have here a function called pre-compute. So initially, what we are doing that in the positions, I'm first of all also adding the night position. That I will tell you why later. कि हम ऐसा क्यों कर रहे हैं, right? But first of all, you will see we are calling this function called pre. This is actually pre-processing the shortest distance between every 2 points. So this pre-function will pre-process and find shortest distance between every 2 points. Let's see what this pre-function is doing. So in this pre-function, we are actually using the a kind of what Dijkstra algorithm actually. Okay, to solve this. So what we are doing, we have this pre-function. Okay, just give me 1 minute. I think someone in the door. Yeah, sorry guys. My roommate ordered some blanket and वो खुद बाहर चला गया था. So हाँ, cool. I'm audible, Ritu Abhinav? Cool.
Yes, sir.
ठीक है. हाँ, so I was saying, let's come back to the problem. I was saying कि I have to first of all find the minimum difference between every 2 points. ठीक है. So I'm actually applying kind of Dijkstra here, but because Dijkstra finds shortest distance from a source to the all the other points, ठीक है, we can actually apply fraud reversal also here. But because here we are not having a basic step, because here we have our cell will take steps like this, right? This. It is not taking a basic step. It is taking kind of this. You will see there is a this distance vector I have taken. So it will either take +1 +2, +2 +1, +2 -1, and so on. ठीक है, मतलब वो एक पॉइंट से there are 4 possible destinations. If your I comma j, night can go to here, which is I -2 comma j +1. It can go to here, I +2 j +1. It can go to here, I +2 j -1. It can go to here, I -2 j -1. Then it can go to these two, and it can go to these two. So these are the 8 distances, 8 directions where a knight can go from I comma j. So those I was told here, right? And I also have a distance vector. This distance vector we actually store that from our index x comma y to, let's say, x2 comma y2, what's the shortest distance. So this distance is actually a 4D vector of size 50 into 50 into 50. So if I will say distance of, let's say, x1 y1 and x2 y2, so this will tell you the shortest moves or shortest distance from index x1 comma y1 to x2 comma y2. And now let's see how we are pre-computing this array. So how we are pre-computing is that we are applying Dijkstra every time from every index. So for example, we are initially at the index. So for every index I comma j, we are calling this function. Okay, this function. So this function क्या करेगा? This function will get that index I comma j. It will get that index, that particular index I comma j, and from I comma j means when source is I comma j, it will find shortest distance to all the other destinations. It will find shortest distance to all other destinations. Kind of a breadth first search we are doing. Breadth first search. कैसे कर रहे हैं? तो initially we are at this start x comma start y. Distance from start x to start x will be 0 only. Now I'm making a call. In the queue starting, we have this initial index only. Now I'm checking for all the 8 directions because we can go there directly. So if that directions are in the range, uski distance हो जाएगी 1 plus the current distance of the current node. And then we will push inside the queue. Let me give you a basic understanding of how we are doing it. For example कि हमारी ये हमारा start point है. We are starting from here. Now from this, or let's say this is our start point. This is our start point. From here, we are finding distance of all the other nodes, that what is the time needed to travel all the other nodes. So initially in the queue, I will add this 2, 2. अब इस 2, 2 के लिए distance 0 हो जाएगी. We know. Now we'll check for all the other 8 neighbors. So first neighbor will be this. Distance for this will be 1. इसके लिए भी 1. इसके लिए 1, 1, 1, 1, 1 and 1. Now these 8 neighbors will be added in the queue with the difference distance 1, like this and so on. अब इनके लिए अलग recursion call गई, like BFS queue, not recursion call, queue will happen, right? So from here we can reach to actually here with difference 2. We can reach here with distance 2 and so on. So this is how, starting from one index, we can find shortest distance to all the other index from that cell. Does it make sense? Simple BFS. Yes, Ritu. Clear है?
ये सर क्लियर है, बट सर एलिस और बॉब जब प्ले करेंगे तो फिर उसका
हाँ,
वो है
वो भी मैंने पढ़ा. ये this is just pre-compute. Don't worry. अभी वो that will come. That logic I will tell you. That's a DP logic. This is just to pre-compute the shortest distance or the shortest number of moves between any to travel between any two cells. वो हम निकाल रहे हैं. वो कैसे निकल रहे हैं clear है ना? How we are finding the shortest number of moves to travel from one cell to another. Is that clear? Ritu and Abhinav.
यस सर क्लियर है सर.
ठीक है. Cool. Now let's move to the next point. अब आते हैं. So once we know between every 2 point, now we know कि let's say start x से new x में आने के लिए इतना distance लग रहा है. That is stored in this distance vector between every 2 indexes. Now comes the main function, this recursion function, which is actually dynamic programming plus bit masking. It is dynamic programming plus bit masking approach. Let's see how we are doing. देखो, as I said, it has a brute force solution only. With bit masking क्या करेंगे हम लोग? Initially ऐसा है, right? So what I will do, my recursive function will have three things. First, it will have int I. Int I is basically or int current, basically int current. So as we know that we have to kill all the knights one by one. Pawns, sorry. We have to kill all the pawns one by one. हम सारे pawns को एक एक करके kill करेंगे. But at what time, which pawn we have to kill, that we don't know. That we have to check for all the possible combinations. So in the function, in the recursive function, first we have int current. Int current will store basically, it will store the current pawn that we are trying to kill. It will store the current pawn that we are planning to kill. ठीक है?
Yes.
Second thing, it will have a mask. Mask क्या होगा? This mask will store the pawns which are already killed. I will tell you how we are handling this mask. Third will be the turn. Turn means which person turn is it? Is it Ali's turn or Bob turn? Two people have the turn ना. Ali's की होगी या तो Bob की होगी. ठीक है. And next, this is the position vector only, which contains the position of all the pawns. That is basic thing. That is not a problem, right? Now understand this thing very briefly. Positions आ गए यहाँ पे. Now what is this mask? So this mask will basically have the value like this. It will be initially, if you will see, initially we are making our pawn like this. 1 left shift n minus 1, where n is the number of knights, right? So initially हमारे जो mask होगा ना वो ऐसा होगा 1 0 0 0 0 0 0. So these bits will represent in this mask. These bits are representing that none of the pawns are being killed. कोई भी pawn kill नहीं हुआ है. That is what it will represent. कि none of the pawns are being killed. That is what this mask will represent. Does it make sense? So each bit of this mask will represent the index of a pawn. If that bit is 0, that means pawn is not captured. If bit became 1, that means the pawn is captured. Make sense, Ritu and Abhinav? So for
Yes.
those who don't have much understanding of bit manipulation, bit mask DP, we actually yesterday had a class at Coding 75. You can get that recording in the portal. So you guys can be check, right? So great. अब देखो, initially when I will call, let's say initially our knight is here. ठीक है? Initially our knight is here. So we are simply making call from n minus 1. So हम पीछे से start कर रहे हैं. From the last knight we are starting. Because the last knight actually में आप देखो यहाँ पर ये है. हमारा knight खुद है. तो हमारे नाइट से हम स्टार्ट कर रहे हैं. हमने अपने नाइट को भी इस पोजीशन अरे में ऐड कर दिया है. तो वी आर स्टार्टिंग फ्रॉम द नाइट. क्या हम अभी कहां पर हैं? हम इस नाइट पे हैं. वी आर एट दिस नाइट. अब फ्रॉम दिस नाइट currently our current is this and our mask is this 1 0 0 0 0. ठीक है. अब मुझे बताओ रितु एंड अभिनव, कितने पॉसिबल पॉन्स हैं जिनको हम किल कर सकते हैं? How many possible pawns are there?
सर एक सेकंड फिर से सर बोलिएगा.
So अभी हम लोग इस नाइट पे हैं. अब फ्रॉम दिस नाइट हैज टू किल द पॉन्स. ठीक है. तुम किस पॉन को किल करें? अभी हमारी चांस एलाइज की है. लेट्स से टर्न इज 1. टर्न 1 मींस कि चांस एलाइज की है. लेट्स से टर्न 0 मींस चांस एलाइज किया. तो अब एलाइज कौन से पॉन को मारेगा बताओ पहले?
पहले 2 3 को और उसके बाद
नहीं. एज आई सेड ऑल द पॉसिबल कॉम्बिनेशन. उस सबको मार के चेक करेगा किससे उसको मैक्सिमम नंबर ऑफ मूव्स मिल रहे हैं. यही करेगा ना अभिनव, राइट? सो वी हैव these 4 pawns. It will check for attacking all the 4 pawns and make a recursion call for it. यही करेगा ना रितु?
यस सर.
राइट. तो करेंटली हम इस वाले पे थे, करंट पे, राइट? अब हम कौन से इंडेक्स में उन्हें निकाले हैं? यहाँ से यूजिंग द पोजीशन अरे हम जिस करंट उस पे उन्हें निकाल लिया, करंट ऑफ 0 एंड करंट ऑफ 1. क्या हम इस कोऑर्डिनेट पे हैं? अब इस कोऑर्डिनेट से हम किस कोऑर्डिनेट पे जाएं? विच पॉन वी शुड किल? तो वी शुड चेक फॉर ऑल द पॉसिबल पॉन्स जो अभी तक कैप्चर नहीं हुए हैं. वो कैसे पता करेंगे? तो फॉर चेकिंग दैट व्हाट वी डू, if it's Ali's turn, Alice will try to maximize the score, and if it's the Bob turn, Bob will try to minimize the score. तो आप देखो दोनों में लॉजिक सेम है. The only difference is सारे recursion calls में से Alice is taking the maximum answer and Bob is taking the minimum answer. And let me tell you what they are doing. So what they are doing, let's say it's the Ali's turn. So it will check for all the possible pawns from 0 to n, which are not visited, which are not captured. How to check that? So if we are, let's say, considering the ith pawn, and the ith bit in this mask is 0. If the ith bit in this mask is 0, that means that ith pawn is not visited. And how we can check whether it is 0? So to check that, it's a bit manipulation thing. If we will do mask and 1 right left shift I, and if this value is 0, that means कि वो bit set नहीं है. So if the ith bit in the mask is not set, that means we should take. But if it is set, means continue. मतलब अगर वो pawn already consider हो चुका है recursion call में, तो continue. But if that pawn is not considered, then find the position of that pawn from the position array, and now your current knight will go to that position. And what is the distance required to reach that position? That you can easily find using the distance vector. So distance of x y next x next y. तो ये आपको बताएगा कि x, y से next x, next y जाने तक what is the distance required. And then you will make recursion call with this distance plus अब आपका पहुंच चुका है ना उस इंडेक्स पे, with that new index where you reached, and in that mask you will make that ith bit set. So if you want to check whether the ith bit is set or not, you use the and if you need to check, you need the or. And अब आपका जो टर्न है वो रिवर्स हो जाएगा, बॉब का हो जाएगा. So basically जो एलाइस है वो क्या कर रहा है, एलाइस is trying to maximize कि सारे recursion calls में से means check for all the pawns and whichever is giving the maximum answer वो return करो. And जब बॉब की टर्न है, बॉब is also checking for all, but whichever is telling the minimum answer, that is what it is returning. And finally we have memoized it using the current and mask. That is always changed. Turn is also changed, but ultimately turn का use नहीं होगा. But you can, if you want, you can memorize turn also. Like it should be memoized. There is some space optimization they did. That's it. Turn 0 1 ही होगा, right? Does it make sense? Ritu,
Yes.
Abhinav. Like please ask doubts. Obviously it's a complex problem. So summing it up, what we did, we first of all found shortest distance or shortest number of moves between every two indexes. Then we're starting from the where the knight is. Now from that knight we're taking all the possible combination. क्या अगर इसको पहले kill करते हैं, कितनी distance होगी, इसमें कितनी, इसमें कितनी, इसमें कितनी. फिर after killing it, makes the next recursion call where in the mask this will be considered as capture or remaining killing next recursion call जाएगी. So ultimately you're checking for all the possible combinations. Here there are a lot of things that are being used: BFS, graph, shortest distance, DP, bit masking. A complex problem, but a greedy problem and a brute force. Right? Not greedy, but brute force. Sorry, not greedy, but brute force. Makes sense, right?
Yes, sir.
Okay. So guys, these are the these problems, these 4 problems of today's Leetcode contest. The time complexity of this, I will say, is order of, so these distance I can consider, but because we are taking just 15 to 50, it can be 50 to the power 4 or n to the power 4 for finding the distance, shortest distance. And then this function recursion call is just taking current into mask, where current is up to n, mask is 2 to the power n, right? So it will be, I think, n into 2 to the power n plus n to the power 4 kind of thing. And it will work because n is very small, just up to 15 it is. Oh, here it is 50 to the power 4, by the way, but it will work, right? ठीक है, तो any doubts, Ritu and Abhinav, in these 4 problems of Leetcode contest?
No, sir. Like इसका बहुत ज़्यादा इसमें concept use हुआ है तो.
हाँ, एक बार have a dry run also after the class. It will be better than for you guys to understand, right? So I'm be recording, starting this recording.